Okay, good morning. Everybody hear me okay? Nick, good morning to you.
Good
You might have
morning.
to, oh yeah, good. You unmuted yourself. Well,
Yeah.
first of all, thank you and welcome thank you for doing this. Appreciate it. We've had a few little discussions back and forth on the line before this and so some interesting stuff. One of the, so interesting, you're in Boston right now doing your medical work. Is that correct?
Yeah. So I spent the past few years in Oxford doing my PhD in neurometabolism, and now I'm starting at Harvard Med School.
So did you do an MD PhD or did you just get a PhD and then decide to go to medical school?
So I actually decided to go to medical school, and then when I was finishing undergrad at Dartmouth, I was accepted to Harvard, but then I got money to go do a PhD over at Oxford, so they let me defer. So I was accepted a little while ago, but I've been in the UK having fun and studying and doing some other stuff. So now I'm returning to do the MD portion. So PhD then MD, or I guess DPhil if you want to be
Yeah, because
thinking about it.
there's some programs that offer like a combined MD PhD.
Yeah, a 242. This was actually more expedited because secret, and Oxford would not be happy with me saying this, but I don't think they can do anything now. Getting a PhD over there is quite a bit easier because you don't have to do the classroom didactic. So I kind of went in knowing what I wanted to do, ran my clinical projects, got in, got out. From the time I matriculated to the time I submitted my thesis was a year and 11 months. So, I mean, I worked hard, but you can do it quite efficiently. So that was a draw. Plus, just getting out of New England because I've lived there my whole life, going to med school there. It was fun to go live somewhere else, and Oxford was phenomenal. I had so much fun.
Awesome. Just looking at your history, you had a kind of history of illness yourself. I mean, you said you were diagnosed with I think relative energy deficiency syndrome. It sounds like some kind of weird thing. You just weren't eating enough.
It's a weird
apparently.
thing. Well, no, I would consider that a misdiagnosis. I can go through my health history. It's quite complicated. Actually, multiple case reports have been written on it, but I also have a video sagaing my health history. I would say REDS ended up being relative energy deprivation in sports, a diagnosis of exclusion, which is medicalese, as you know, for none of the above. I didn't fit it at all. Normal BMI, normal testosterone. There are other things going on that I think had to do more with what you and I would agree is just general metabolic health. I just manifested it kind of weirdly, these metabolic dysfunctions, as things like weak bones and leaky gut rather than obesity, just because of my own diatheses.
And then you ended up with ulcerative colitis as well, which was something that you figured out. I guess you went on a ketogenic diet, and that helped, correct?
Oh, that was phenomenal. I mean, for me, it was, suffering with multiple years from osteoporosis. I used to be a competitive athlete and then, lost one of my sports running from that. Took forever to get a diagnosis, and then there was no etiology. Then I was being fed advice about, 5 a day, having your whole grains, lots of carbs, because, you want to address this REDS thing, right? A little while later, I developed ulcerative colitis. I then got really sick. So when I was in Oxford, actually at Climax, right after I moved, I had a flare so severe, I ended up being rushed to the hospital after losing about 15% of my body weight, and I had bradycardia with a heart rate in the 20s. They put me in a palliative care ward. And then they discharged me with a heart rate in the 20s, saying that it had to do with turmeric, which I was prescribed for my ulcerative colitis, saying I literally had a heart rate in the 20s because I had too much turmeric in my diet, which is, what is your opinion of that as an MD?
I would say that strains, credibility, but I can't say I've just, I've examined turmeric overdoses, but I would say that doesn't sound particularly likely. But
no, it was the half-life of the compound 6 hours. I was there for 4 days. It didn't change. But anyway, that was just all a prelude to say, it was at that point that I really started experimenting with diet. After years of that, I just became a little bit desperate. So I didn't have any expectations, but I started experimenting with diets, including basically every diet you can think of: specific carbohydrate diet, low FODMAP, not gluten-free, casein-free, vegan, vegetarian, pescatarian, Mediterranean, until I went keto. And then it was like a light bulb went off for me. I mean, my inflammation disappeared within a week, along with my symptoms, and they just never came back. And I'm off my meds now, and they've never come back. I just feel on top of the world. It was just a transformation for me. That was my personal experience with it. And since then, I've gotten quite involved with the research and with the community, and realized, I feel like a broken record saying this because I always say it, but that the most unique thing about my story is that it's not at all unique. You have the stroke come up again and again of people suffering with metabolic diseases, whatever they may be they neurological, be they obesity, be they diabetes, be they, inflammatory bowel diseases, and things don't work. You get a little desperate, you grasp for straws, then you find, metabolic medicine, therapeutic carbohydrate reduction, carnivore, keto, whatever it is for you, and it works. It works really well. And then you're just like, I've been to dozens of doctors. How did nobody tell me about this? And I see this happening all around me too with other people. Why is this not part of the standard of care? And then you get quite passionate about making it your mission to make it the standard of care. So that's where I am now.
Yeah, one of the things I saw, I think you posted that, because you had lost a lot of weight, and the advice was just eat whatever you can, junk food as much as possible. I think there's better ways to address that. But who gave you that advice, and what was the result of that?
Yeah, I won't name names, but it was, I went to my endocrinologist. They referred me to nutritionist, who said, you have this diagnosis of exclusion, REDS, relative energy deprivation in sports, which is basically, it's a gender inclusive version of what's called the female athlete triad, which is when women restrict and they lose their menses, they get weak bones, and they have an eating disorder. And to the credit of the people that were treating me, they dealt with a lot of women who had anorexia. They couldn't figure out anything wrong with me, so they made sense to give me this label. And they didn't, it's hard to think that somebody would listen to, at this point, I was a 17, 18-year-old kid saying, listen, I don't think this makes sense. I'm looking at the literature. These women who have been anorexic for, 6 years with BMIs of 11.7 have T-scores, Z-scores, -1.7. Mine's -3.3. And, my BMI is normal. My testosterone is normal. This doesn't make sense. I eat well. Like, I would get back from runs and drink a jar of Nutella because I worked out really hard, but, so I wasn't restricting by any means, but this was the diagnosis of exclusion. So compounded on that, I was being told, oh, just eat more at all costs. And they probably thought I had an eating disorder. So I was getting calls saying, literally calls to college, have you had your 5th serving of carbohydrates today? And being a compliant patient and just a kid who wanted to believe in the authorities that were handing me advice, because I had a lot of confidence in them. Like, what did I know? I was a kid. I was compliant. It made me feel terrible. And I said that. I said, my stomach's killing me. I'm breaking out. I can't think straight, but I was compliant. And then the osteoporosis happened and I was still compliant. And then I had that bradycardic episode when I was in a palliative care ward for a while. And that was the straw that broke the camel's back. So, I'll not name names. And I just want to point out, at no point, although I do sometimes express frustration given my narrative, want to be seen as doctor bashing in a sense. Everybody that worked with me, almost everybody, was phenomenal. And a lot of them later down the road came around to my way of thinking when I presented some other data, alternative hypotheses. And so we're quite open-minded about it. And, I don't know how you feel, but I think it's somewhat of an unfair expectation to believe that doctors are omniscient and know everything. And it's sad. I wish they were taught, doctors, healthcare practitioners in general were taught good metabolic medicine, but they're not, and that's not necessarily their fault. Like, doctors are people that went to med school, so 4 more years of education plus residency. They just have a little bit more schooling. But if none of it focuses on nutrition, why should we expect that they hand that down? So I wanted to believe, at least as a kid, that my doctors knew everything about how to fix my health. It just turned out that's not the scenario, and it's not their fault. It's just a shitty situation right now.
Yeah, I can speak as a physician. We certainly don't know it all. There's many holes in a physician's expertise. If you get to specialists, they pretty much tend to lose a lot of the other stuff they learn in medical school, and not everything you learn is accurate, and you forget much of it. But I also am not typically engaging in doctor bashing. I think there's a system problem, and I can bash the system. And I think there's a lot of good people within the system that want to do the right thing. But as you pointed out, they just don't have the knowledge that's there, even though they have a lot of knowledge about certain things, how to, administer drugs and do procedures and diagnose certain things, but they don't necessarily have the knowledge and treatment in all cases. Did you ever figure out, this RED syndrome or RED's condition, and you kind of said that's probably not what's going on. Was it just all basically, something to do with ulcerative colitis, or what did the ultimate diagnosis come to? Figure it out?
We don't need to go quite too far down that rabbit hole. I will tell you, I dug into it quite a bit. It has to do actually with the quirk of my genetics. This was, I think, my first authored paper, actually. You can look it up. It was something like LRP5 and mechanical stress. It was in Frontiers in Endocrinology, I think. And it was a couple of years after my diagnosis. I had just finished undergrad and had a little bit of free time, so started to dig in, and I got a full genome sequence on myself and started leafing through things, and actually stumbled across this interesting pathway, and had this weird mutation, this variant of unknown significance. It was a alanine to valine 745 point mutation in this gene LRP5, which controls Wnt signaling. And the hypothesis I posed in the paper, and the people that diagnosed these in Reds actually signed on as co-authors, had to do with basically modification in this gene altering my body's response, at least my bones' response to mechanical stress. So whereas, generally mechanical stress, it strengthens your bones, just like lifting weights will strengthen your muscles. But in order for that to occur, you need, your genetic program to deploy. When you work out, your muscles grow because at some level there's gene modification, changes in gene expression, and that mediates the effect of muscle growth or bones getting stronger under mechanical stress. And I have a mutation in this pathway, and I created a nested model based on genetic human data from particular conditions, and rodent data and some in vitro data, and published that. So I think I'm actually the only documented case of this. It's a little bit weird. It's a very rare mutation. That said, there is almost certainly a larger picture involved for a few reasons. One, there's a lot of research that I wasn't able to put in the paper just because when you're publishing a paper, you have to be kind of focused, but more relevant clinically. So the treatment I went on for osteoporosis was sequential treatment with basically the two most potent bone anabolic agents there are, Forteo, or teriparatide, and then Prolia, or denosumab. And that sequence is very aggressive. And while I was on it, but not checking into my nutrition, while I was also, trying to eat by the standard guidelines, more or less, my bones got better, but only at certain sites. So my spine got better, but my hip and my femur didn't. They remained very weak. And then interestingly, when I went keto, despite losing weight and having my thyroid go down, all sites across my body improved, including my hip and my femur, the cortical regions that hadn't improved before, which leads me to think that there was a nutritional component. I don't think it had to do with the colitis because of the sequence. The colitis was diagnosed years after. And when I was diagnosed with the bone disease, I didn't have any overt markers of inflammation, although a comprehensive cytokine panel wasn't done. My hsCRP was actually pretty low, although I had high inflammation in the gut. So I found something that worked. I don't really know how it worked, to be honest, but it worked, and that's all I care about in terms of my N=1.
It's interesting to see these sort of genetic, genetic disorders, diseases, whatever. I was really, when I first started doing this carnivore diet, I started finding people with Ehlers-Danlos syndrome, which is a connective tissue genetic disorder that became basically asymptomatic. The tissue laxity, the dislocations of the joint reverse, which really perplexed me, but I guess it must be some sort of epigenetic modification, or it's only expressed in certain environments to where if you change your diet, that environment has changed. The nutrition may have an impact on all these things. So it really, maybe it alters some of our genetic, and we've got somebody in the comments saying EDS is so much better on carnivore, which again, genetic disease, but better. I guess you could argue that, some aspects of diabetes are there's a genetic component to that. And so we're seeing a lot of that stuff now.
Everybody has their genetic diatheses, their predispositions. It just so happens that I identified mine, but I don't think that means I'm unique. We all, like I said, manifest differently. So, the analogy I always use, and I'm sure somebody else came up with this before me, but I still think about it, is that metabolic diseases are like a tree. And we look at the tree as its individual branches. Each branch is a disease, like obesity, osteoporosis, whatever. Each branch has its own symptoms or foliage, but really they connect to a common core, a common trunk, those metabolic dysfunctions that we talk about, insulin resistance, inflammation, and that's all fed by things like nutrition. So what was I going to say on that? I forgot. I had another point. Maybe it'll come back to me.
Let me ask you, you've got a paper that I guss it's in preprint. I don't know if it's you, because you mentioned that.
That reminds
So
me what
we've
I was going to say. Yeah.
Yeah, we've got this the situation ApoE4
Yeah.
gene, which is, has a higher correlation with dementia, particularly Alzheimer's disease. And you've done some work regarding that. So I'd like to hear your input on that, because a lot of people ask me about that. And, I tend to give them the standard advice to, maintain, general health, maintain lower insulin levels if possible, and so on and so forth. What's your thoughts around ApoE4?
Yeah, well, that actually reminds me that's what I wanted to talk about. I can't believe I forgot. Yeah, this morning I had a paper come out in Nutrients about this gene ApoE4, or the gene variant ApoE4, which codes for a mutated lipoprotein. So we have our ApoBs on our chylomicrons and our LDL particles. We have our ApoAs on our HDL. We also have ApoEs. It's a lipoprotein that's peripheral, but probably as important or far more important centrally in the brain. And a variant of this ApoE gene, ApoE4, carried by about 20 to 25% of people, is the leading genetic risk factor for Alzheimer's disease. So if you have one copy in your genome, it increases your risk about 2 to 3-fold. If you have 2 copies on a population level, it increases your risk 12 to 15-fold. And this is actually the other thing I wanted to come to, because I think it's a key example of how, as you were just describing, for the most part, there are certain diseases like Huntington's where, it's a genetic cause. But for the most part, genes load the gun, environment pulls the trigger. That's true with my probably LRP5 gene, evidenced by the fact that, I'm now getting better. And with ApoE4, just because you have this gene variant does not mean you will get the disease. And we know that from population studies. So, for example, if you look at Western Africans, Nigerians who live in Nigeria, they have a pretty high prevalence of ApoE4. They should be at elevated risk of Alzheimer's disease. But if you look at Nigerians who have ApoE4 and those who don't, there actually is no difference in Alzheimer's prevalence. But if you compare individuals of that genetic ancestry living in Nigeria or living in, there was an Indianapolis population, and they compared the Nigerian and the Indianapolis African populations, the Alzheimer's prevalence was twice as high in the individuals living in America, the African Americans versus the Africans living in Africa. And other studies have been done too, looking at people eating more traditional diets over in Southern Italy versus Southern Italians in the United States. And again, it's the same thing. The Americans, they die early, have Alzheimer's disease, and the people with similar genetic ancestry, despite having ApoE4, have the same chance of living into be extreme old age, 95 for men, 99 for women, top percentile. So what we do know about Alzheimer's disease in the vast majority of cases, 95% of cases, is environment is mediating, regardless of your genetic risk. And the way I think about it is ApoE4 is just kind of a multiplier for poor lifestyle choices. So you're much more vulnerable. We talk about this number, I'm sure everybody that's listening to podcasts has probably heard this, 88% of Americans are metabolically unhealthy. The way I would put it is if you have ApoE4, especially if you have 2 copies, you can't get away with being in the 88%. You need to be in that 12%. So first things first, I would agree with you, is that the low-hanging fruit for preventing any metabolic disease, but including Alzheimer's disease, is getting in that 12%. Getting your metabolic health in check. That means, getting insulin sensitive, reducing inflammation, whatever that means, whatever form of nutrition that is for you, carnivore or otherwise. And then beyond that, we're all unique. And so you can come up with kind of precision mechanisms to target pathways in which you might be deficient, or little things that you might need. And you can do this based on metabolic testing or genetics. So that's the paper we published this morning was a paper looking at all the new literature on how ApoE4 alters metabolism in the brain, changes things like blood-brain barrier function, astrocyte function and lipid metabolism, insulin resistance and glucose metabolism. And then, based on these mechanisms, building a bottom-up approach to precision nutrition for Alzheimer's disease. So that's what this paper was about. It's something I've had quite a few papers of the past couple of years. This is one I've always really wanted to write because there's nothing quite like that out there. There's a lot of papers out there about Alzheimer's disease, but they're all, while important, about treating symptoms once the disease is manifested. And this is a disease that starts in your brain 20, 30 years beforehand. So by that point, the boulder's rolling down the hill. Like, you can maybe slow it, but you're not going to stop it. So what you need to do is intervene early, and we're not going to have those clinical trials. You probably never will. So what we need in this case, I think, is just a mechanism-informed approach so that people that carry ApoE4, again, the most at-risk genetic group for, I think, the scariest condition in the world, Alzheimer's disease, they have something to try. You don't have to just sit there twiddling your thumbs being like, oh, I know I have it, but so what? Let's just see what happens.
One of the things, I started following on Twitter a while ago, and I noticed that, you've got this fact of the day. You put up some medical scientific fact of the day, quite interesting. One of the ones that really, it's surprising, but not surprising, diabetes in the United States, $1 billion a day we're losing or is going towards diabetes. As you know, that diabetes and Alzheimer's disease have a significant relationship, whether it's causal or not, or linked certainly. What are your thoughts on, well, let me ask you this in the big picture. So you've got your PhD, you're going to go to medical school. Is your plan to practice in medicine, or do you have an overall plan down the road here?
Yeah. I mean, my plan for the next 4 years while in medical school is to start to bring just metabolic health to my peers. Thereafter, I'll probably do a residency in just internal medicine or endocrinology, and a fellowship in hopefully metabolic health will be a specialty by that point in time. I'm trying to work to make it so, even if it's through SMHP or something. But I do need to be, I think, within an academic center just because I love the research and the resources afforded by it. That said, I couldn't deal with the model we have now of seeing your patients for like 15 minutes just in succession, and that pressure that I know doctors deal with. So I'll have to find a balance there. Maybe I'll start my own clinic while having an appointment and lecturing and doing research. I'm not sure. I think I still need to suss that out. But the only thing I can tell you for sure is I can't stand specializing in a particular organ and only treating that organ. I need to look at things systemically. I love those big picture puzzles. Like, I mean, my PhD is in neurometabolism, but over the past 2 years, I've published on osteology, lipidology, cardiology, gastroenterology, neurology. It's so much fun for me to just shift gears and look at something else, because inevitably what happens is these things all relate. So just for example, that esoteric thing I told you about LRP5 and my genetics, I started looking at that cascade, that this LRP5, it controls Wnt signaling. And I realized this Wnt signaling is everywhere, including in Alzheimer's disease. So then me and one of my friends at Oxford, Dr. Soto, wrote a paper on Wnt signaling, type 3 diabetes, Alzheimer's disease, and the interaction there, and basically used this Wnt signaling thing that I really learned about from studying bones as a model for this multi-loop model of Alzheimer's disease, which we talked about pulling in this type 3 diabetes thing. And just as a quick random aside, one of the proteins in that cascade, that Wnt signaling cascade, is a convergence point of insulin signaling. It's called GSK3 beta, glycogen synthase kinase 3 beta. And you can tell by its name what it does. It's the glycogen synthase kinase, it phosphorylates glycogen synthase to alter glycogen storage. So it's very involved in diet, but it goes by another name too. Its scientific alias is tau kinase 1, because it is the primary or one of the primary proteins that phosphorylates tau, which is a key marker in Alzheimer's disease. So in the standard model, you get amyloid, and amyloid leads to tau, and then tau is associated with Alzheimer's disease. But what links them? One of the things is this GSK3 beta protein, which has a direct input from Wnt signaling and insulin signaling. So I think that's a long way of saying you learn so much and get so many cool different perspectives if you can look at things in a systems perspective. And anybody that's studying metabolic health is effectively doing that. So that's what really excites me about metabolic health as a potential fellowship or specialty. We'll see if it precipitates.
Yeah, I mean, so when do you start? Do you start classes this coming fall, or when does it actually kick in? Or have you already
Yeah,
started?
matriculation is August 2nd.
Okay.
So the class has been announced, and we're starting to get together as a community, which is quite fun. And I've actually been hosting lectures from the SMHP. So Doug Reynolds at Society of Metabolic Health Practitioners is letting me like invite people to grand rounds, but also have people come talk. I don't know if you know like Dr. Mariela Gallant over in Israel. She's an endocrinologist and low carb diabetes expert. Dave Feldman's going to come talk to us this weekend about his lipid energy model and upcoming lean mass hyperresponders study, which we were talking about beforehand yesterday, which seems really exciting. I know we're going to talk more about that, me and him, but the papers are coming together. So I'm quite involved right now, and I'm getting a sense that a lot of the incoming class is also at least open to this metabolic health idea. But to answer your question shortly, we matriculate this summer. Um, that's the answer.
Yeah, so good. Having done that, that was a long time ago for me, where I went through all that stuff. But you'll have a lot of fun with that. I think it's a great time. But a lot of, as you probably know, a lot of just memorizing and regurgitation of data to do that stuff. Let me ask you about because you mentioned this metabolic health, and there are some people that there's lifestyle medicine and some other specialties out there that do have at least a concern about nutrition. And that has been largely founded and sort of dominated by these folks that promote a plant-based diet. That may, obviously that tends to be the prevailing thought right now. These crazy people eating meat, they're just killing themselves or giving themselves colon cancer and heart disease. Do you have any concerns about that? Have you run into to sort of pushback from those folks?
Yeah. Yes, quite frankly. And I think my perspective aligns a lot more with yours on the legitimacy of the data upon which their ideas are founded, which is largely population-based studies, epidemiology. And it's a shame to the degree that the public gets misled on the topic of plant-based nutrition. And by no means am I saying that we didn't evolve eating plants, that we can't eat plants, or that plants are by in and of themselves toxins. But you just see things, I mean, at every level. We could talk about how certain plant-based advocating RCTs, even crossover RCTs, were conducted. I read one recently, and I hope the person doesn't come after me for this because I actually do respect him as a researcher, but it was like, a crossover metabolic ward RCT concluding that, low fat, like whole food plant-based diets were better than like low carb, high fat diets because they contributed to decreased energy consumption. But then you look at the study and it's like, okay, there's no run-in period. There's no washout period. Yeah, it's a metabolic ward study, but you're now taking people who are overweight and probably insulin resistant. I think mean BMI was 28. And then you throw them in a room with nothing to do really than snack. And you're giving them ad libitum high-fat foods. Are these high-fat foods that you would eat? Fatty ribeye steak? No. If you look at the supplement, you can dig into the supplement. You see pictures. It's like store-bought mayonnaise, American cheese, which is basically just like plastic, and the snacks are roasted salted nuts ad libitum. Again, these people are insulin resistant, no run-in period. You're just throwing them in a room. Versus like the ad libitum snacks for the low-fat diet, like dried apricots and dried soybeans that are unsweetened. Like, yeah, if I were insulin resistant, I'd eat more roasted salted nut calories too. But then the conclusion that's popularized is, eat whole food, plant-based, and you'll eat fewer calories. And then you go look at things like the documentaries that are put out, the game changers, and it's almost shameful. It's like, well, first of all, they conflate health with athletic performance. Yes, you can be a plant-based athlete, including a strongman that had that, like Patrick Babuyan guy was the face of them, but that doesn't mean you're actually healthy. In fact, I find it really ironic. If you watch that documentary, The Game Changers, the very last scene is a very clearly obese man eating like pizza, pasta, and veggie burgers all at the same time. And yeah, he's strong, but he's not healthy. Like you can get big. He's like, oh, I put on a lot of weight when I went plant-based and I gained a lot. Like, yeah, like you spiked your insulin. Like, I wasn't surprised you can put on, mass. And then the experiments that they did that were just, poorly performed and misleading. Or, and this is just general to the population, it's like, what's your point of contrast? So often our point of comparison is a standard American diet. So if you go from a standard American diet to a vegan or vegetarian diet, you're going to improve. And guess what? Good for you. If you're doing this and it's working for you and you're sustaining it, then like, by all means, continue. It's better than the alternative. But when you say that is optimal, I think that's a little bit misleading. So just as an example from that documentary, that is one athlete, and he's like, yeah, I went plant-based, I felt so much better. Before I went plant-based, I didn't even know what asparagus was, and I was getting all my protein from Kentucky Fried Chicken. Like, if that's your point of comparison, then yeah, you might have improved a little bit. And so I think there's a confusion about what is better than the alternative being standard American diet, and what is optimal. So, certain nutritional approaches, including whole food plant-based, I think I would consider them, they're in the right 180 degrees, but they're not going straight from point A to point B. They're kind of orthogonal. And so I don't think we can ever be going straight at optimal, but in order to be going straight at optimal, we always kind of have to be I don't know, tweaking and adapting our nutrition journey. I think people get stuck in one place or another. So my personal perspective is, because diet is pretty individual, it's always worth tweaking and seeing where you land. And individuals like yourself or Michaela probably do by far the best on just full-on carnivore. I myself, I find that I do best on a carnivore-ish diet, largely animal-based. I do like some 100% cacao, like some coconut butter and like olive oil, and I love fish. But that's where I am, and I'm still tweaking it. Other people, it's a little bit different. I don't rule out the possibility that some people really do best with plants. I just, based on my reading of literature, it seems unlikely to be the majority.
Yeah, I think it's one of those things. I guess you're early on. You're referencing, I think, the Kevin Hall study where they basically put the people in a room for 3 weeks. It was a crossover trial, and I think it was a crossover. I can't remember, but
yeah, it was.
And, like I said, you're right, the food selection. And I guess this is a problem with any sort of diet, because the other thing is just, you instruct people, go home and eat whatever you want, and then but you've got, so it's very difficult to do high quality nutritional research, even within the context of a metabolic ward, of what's going to really happen in real life. So I think,
it was Kevin Hall. I was trying not to name him because I'm not trying to point a finger at him individually as a researcher. I don't think he's that problematic as compared to other people. It's almost more how then the media manipulates the story of that study. That said, I mean, I wouldn't have designed that study that way. And there's other ways to go about designing studies that I think are a little bit more robust, even if it's just having, a longer period on a ketogenic diet, or doing a mixed model thing where you do standardized meals and then you do free living experiments. And so there are various ones that are done there. I think David Ludwig was it David Ludwig that had one? That was the nucleus accumbens study. I heard you talking about it with Ben Bickman. I think that was, I read too many insulin papers not too many, but over the past couple of days. It's the 100th year anniversary of insulin, so they're all hitting my inbox. But I think that was the one in which, never mind.
Yeah, David just put up. Yeah, David senior author on a paper that came out the other day, looking at regional cerebral blood flow with carbohydrate, various carbohydrate percentages, and saw that the lower the carbohydrate, the less cerebral blood flow to, I think, the nucleus accumbens, which
higher carb, it was 43 to 51% increase in nucleus accumbens blood flow. I just forgot the way that the study was designed. It was a follow-up on their earlier study, and just looking at, how eating different carbs. It was the cool thing, and this is what David Ludwig does well, or the Hyde 2019 trial, the one in JCI about metabolic syndrome, is, really trying to make the steel man argument against themselves, and saying, like, look, in both these cases, even though we know, say, low carb will make you lose weight, it's pretty effective for that. We're actually going to control for that. So in this particular study, or in the Hyde trial, like, they basically force people, if they're gonna, eat fewer calories on low carb, to eat to weight maintenance. And this has been done in other studies as well. Then to see what is the independent metabolic advantage of the low carb. And so, David Ludwig showed in this trial that there was a decreased blood flow to the reward center of the brain, the nucleus accumbens, if you ate a lower carb diet. And there was some stuff with insulin sensitivity that was a little bit speculative and interesting for future research, but I didn't really grasp the full implication of that, I think, in terms of the correlation from baseline. But
yeah, I mean, I think the one study that Kevin Hall did, which was, well, I mean, he's done many, obviously, he's an accomplished researcher, but the study looking at ultra processed food showing just a spontaneous overeating, basically. I mean, I don't think that surprises really anyone. And, the thing that, this frustrates me is, we kind of, even if whether you're a vegan or on a carnivore end of the spectrum, we all agree that this process, the Oreos and Doritos and that stuff is bad for us. And yet we don't have any kind of real policy or recommendations to say just don't eat that. Instead, we just eat it in moderation, which most people find it very challenging to do. Some people can, but most people can't.
I don't think, I 100% agree with you. So, like, I mean, just unifying where we all agree, Kevin Hall and say us, it's really the ultra processed foods that get us. And it's crazy if you look at the data. I think this was a 2016 BMJ study. 60% of Americans' calories come from ultra processed food, not just processed, but ultra processed. And then if you actually start to look at the neurobiology and systemic biology of these foods, it's kind of criminal. They are addictive substances. Like, you give processed sugar to rats and you will cross-sensitize them to cocaine and amphetamine. It acts on the same systems in the brain. In fact, Michael Moss just wrote a book on this, Hooked, about how the processed food industry basically goes about hacking our brains. And these are addictive substances. And so it's completely unfair to tell people to, quote, eat in moderation or eat intuitively. I hate that advice. And it's like, it's well-meaning. And superficially, it sounds so good. How can that sound wrong? Listen to your body is wise, give it what it needs, eat intuitively. But I'd analogize it to giving somebody directions to point X by saying, and then arrive at point X. Like, it's the goal. Yes, it's the holy grail. It's where you want to get to. But the directions you're giving to just say eat intuitively, eat in moderation, they're useless, practically speaking, because they don't actually give you any path to get there in the environment we're in with all these ultra processed foods. And I think that's the real value of achieving metabolic health through something like just clean keto or carnivore is, and you have more, experience in this realm, so you can, confirm or deny what I'm saying. It's, but like, when people do eat, let's say carnivore, they get to that point where they're like, now I know what it is to be hungry and actually eat intuitively and just eat when I want to eat and give my body nourishment, listen to my body. And you can't do that until you get rid of the obscuring force of these cravings and, the insulin roller coaster. So to eat intuitively, you have to fix your metabolism first. And that requires eliminating the ultra processed foods, just like an alcoholic would eliminate alcohol.
Yeah, the overlap, this is something that has really surprised me, particularly early on when I was kind of seeing this phenomenon happening is, you mentioned the cross-reactivity of the reward centers. And I see repeatedly people that are alcoholics, that are, addicted to recreational drugs or cigarette smokers, and they go on this carnivore or some other diet similar, and they end up being able to quit those things. And I think there's something going on. And maybe, I don't know if you looked into the details as to why that might be. I mean, it's fascinating. I guess if you were to look into the food science literature, particularly as it's been designed, the Michael Moskowitz bliss point stuff back in the 70s, I'm sure it's fascinating reading, and it's probably right out in front of us, but we're just, and we're seeing these effects in society. But can you talk a little bit more about the brain physiology and addiction and how food?
Yeah, I mean, first of all, I don't mean to be an expert in the area of food addiction. It's somewhat new to me, but just a high level concept, because then I can relate it to a couple other things, is mental illnesses, including addiction, including eating disorders, including schizophrenia, whatever, they're metabolic diseases. They are fundamentally metabolic diseases. They have the same pathologies: insulin resistance, oxidative stress, inflammation, etc. In fact, I wrote a paper on this that was entitled "Ketogenic Diets as Metabolic Treatment for Mental Illnesses" with Chris Palmer last year. You can look it up because it has a nice little video abstract where we make this point that all of these neurological diseases and mental illnesses, they are fundamentally metabolic diseases, and that includes addiction. So it only makes sense that if we address the metabolic pathologies, it would lay the groundwork for helping these conditions get better, whatever they are. And Chris Palmer has some amazing examples of schizophrenia. There are, published examples of binge eating disorder, and even things, this is going to be a little controversial, but you wouldn't expect, like anorexia. I don't know if you know Michelle Hearn, Sean, or have you talked to her?
Yeah, I've interviewed Michelle twice, actually. Yeah, I know Michelle.
She's fantastic. And I read her book. She came out with this new book, The Dietitian's Dilemma, which is phenomenal. In the whole beginning section, she, bears her soul, so to speak, about her struggles with of anorexia and how fixing her metabolism through a low carb, keto carnivore diet really helps her overcome it. And I actually hear this quite a lot. I published an article in STAT, which is the health arm of the Boston Globe, last Friday, and I got a few personal emails. And I think, so you can see in the comment section, some people were even saying, I had an eating disorder, I had anorexia. And weirdly enough, it got better when I went on this, quote, restrictive diet. Why? Because metabolism improved, brain function improved, and for other reasons as well, having probably to do with things like sugar addiction. What happens when you give someone who is using food restriction as a point of control an addictive food and they feel out of control because they have these urges? It's going to cause things to backfire, leading to high relapse rates. In terms of the addiction literature, I know just a little bit. I mean, I think also Chris Palmer a few people tweeted about, there was a new trial showing that ketogenic diets help people with alcoholism remain in remission and stop consuming alcohol. So I think it has broad applications in mental health, including lots of different forms of addiction, by just addressing the underlying metabolic pathologies that are common to all of them, that are common to diabetes and depression and schizophrenia, anorexia, etc.
Yeah, and we have just countless examples, and including people in here today, talking about overcoming binge eating disorders, depression, all those types of things, anorexia, and they've all been helped tremendously by switching to low carb or carnivore type diets, and so that's we definitely see that. I saw you were, I was just looking at some of the stuff about fructose. Do you have any comments on fructose? It seems to be a point of contention. Some people, fructose is perfectly fine. Other people think it's a poison. I think there's something in the middle. There's probably an amount that's okay for some people, and we overconsume it, particularly in forms like high fructose corn syrup.
Oh yeah.
Any thoughts on fructose? That's one that kind of goes back and forth.
Well, I'm having a little bit of, I was listening to, before I just got on here, I had a free hour. I started listening to your last episode that I heard on with Ben Bickman, and was thinking, oh crap, with anything with respect to sugar or insulin, I have to follow Ben Bickman. It was the last time I felt this traumatized. I was giving a speech in front of 11,000 people right after following a professional comedian. I was thinking about that when listening to that. So shame on you for asking me about sugar metabolism and insulin resistance after Ben Bickman, because I don't think I can follow that. That said, I did learn from him in your last podcast. I was listening to this, and what he said that really caught my eye, I think I just tweeted it a couple minutes ago, was that basically fructose sensitizes fat cells, if I'm getting this correctly, to cortisol, which is interesting. But also he was commenting that visceral fat, which is the unhealthy kind of fat you hold in your gut around your visceral organs, and subcutaneous fat, which is the more healthy type that just sits under your skin, they respond to insulin differently. So whereas subcutaneous fat, cortisol will stimulate lipolysis or fat breakdown, and visceral fat, it will contribute to lipogenesis or fat accumulation, such that excess fructose will basically cause a shunting of fat from healthy stores to unhealthy stores. Tell me if I got that correctly based on what you remember talking about with him. Does that sound accurate?
I think that sounds pretty much, you got the gist of it.
And so, I mean, that's just one more piece of the puzzle. And now he also caveated that, having a little bit of honey isn't going to kill you. And I agree. I think that, the dose is in the poison. And there's also evidence, there was a paper showing that if people talk about fructose getting primarily metabolized in your liver. Now, I know Ben said something about the fat cells as well, but there is a paper about the small intestine acting as a first line of defense to fructose. So where at levels up to 1 gram per kilogram, the small intestine will actually convert fructose to other sugars. Presumably, I think they said in the paper to protect against liver toxicity.
That was a rat study. I've read that paper.
Yeah.
That was a rat study. I was trying to calculate what it meant for humans. It was like,
I know. I was trying to. I've done some just like fun for thought experiments, but I mean that was the saturation point in rats who have a faster metabolism than humans. So maybe it's not a perfect comparison, but all things being equal, saturation even began to like start, or level of conversion, I think, started to change at 0.5 grams per kilogram. Now, for an adult, that might be a lot, but when you think about what we feed kids for breakfast, or when I think about what I ate for breakfast when I was like 12 years old and whatever, 60 pounds, like half a box of cereal with a banana and orange juice. Like I am way over that threshold in breakfast easily. And then we're seeing all these things like gestational diabetes. I just think it's interesting. And I think fructose is problematic. I wouldn't have too much of it. Again, I don't think, as say Paul Saladino does, having a little bit of honey or buckwheat honey, and I have some of that every now and then, say after a workout, is going to be bad for you. But I definitely don't think that foods that are quote natural, like tropical fruits, are by any means healthy. Like a banana, papaya, mango. And just as a complete aside, the notion that these foods are natural is, I think, a little bit misleading, because if you think about like what a banana looked like 6,000 years ago, before semi-modern agriculture, it was like the size of an apricot with giant seeds and very little sugar. Like the fruit we have today is, first of all, we were working really hard to get it. We got it infrequently, and it is not the fruit we now have in the grocery store. So, I mean, I could pose the thought question, like, is a banana a processed food? I would argue that actually, yeah, a modern banana is very much a processed food. So what else did I have to say on? Yeah, that's fructose and that insulin stuff, I think, is very interesting. Just in general, a lot of I don't know if you've been getting all the notifications, but there's so many cool insulin papers coming out. Did you read the one about, you would love this one, how the review, there was one on insulin sensitivity and muscle metabolism, April 6th, I think. It was a review. I think Cell was putting out some special reviews. They had one on adipocytes, one on muscles. The muscle one was like the densest one I read, but there were some really interesting things in it. I don't know if you saw it.
I think I did. I don't remember if I read the abstract. I know that I've looked at a lot of them recently, but I know I've seen there's been a whole bunch of stuff on muscle, and I read a lot of that. It's
so cool. Like there was one pathway I was reading about. They were talking about the back road by which muscles, basically workouts, exercise, increases glucose sensitivity in muscles and insulin sensitivity. This protein, TBC1D4, but they're talking about, when insulin stimulates the insulin cascade in say a muscle cell, that activates PI3K, AKT, and then this protein TBC1D4, which helps glucose transporters get into the sarcolemma, the muscle cell membrane. But that muscle like exercise, muscle contractions independently, they activate it through a back road, actually through activation of AMPK. So presumably fasting might do that as well, so that you can be sensitive to glucose and have your muscles preferentially uptake glucose, which you probably know, following a workout that's insulin independent. But another cool thing about this mechanism was the phosphorylation site of the TBC1D4 by that AMPK pathway was distinct from the insulin pathway. So it ends up sensitizing the muscle to future insulin. And that for 48 hours after a hard workout, your muscles are more insulin sensitive as well, which is fascinating.
Yeah, I think there's been a number of studies that have confirmed that or shown that. That's something.
It's really cool research. And then there was one on, this was cool, TUG, which is really nicely. So TUG is the tethering protein that holds glucose transporters inside. This is a rat study inside of cells. And the mechanism by which insulin stimulates glucose transport in part has to do with the cleaving of this TUG tether. So insulin basically stimulates a pathway that causes it to, snip the tether, the TUG, so the glucose transporter can go to the cell membrane, the muscle cell membrane. And this is associated with the thermic effect of food. So when you eat, you burn more energy. About 10% of your calories burned come from the thermic effect of food. But the really interesting thing, and this paper they were showing, is that it's not the glucose transporter going to the muscle cell membrane that actually sends the signal for the thermic effect of food, but rather when you cleave the tug tether, the C-terminal fragment of that protein activates, I think it was PPAR gamma and PGC1 alpha, and that causes the thermic effect of food. And they did that with some like cool knockout and constitutive cleavage of the tug protein mice. But then the implication was, and they showed it in the study, you give the mice an obesogenic diet, and then basically it attenuates the thermic effect of food, which is really fascinating. So basically, big picture, insulin resistance would decrease the calories you burn from consuming food. And what I love about that, and coupling that to say with the David Lugley paper we were talking about earlier, where higher carb diets lead to more activity in the reward center of the brain, presumably leading you to craving more, is it sets up this vicious positive feedback cycle between obesity and insulin resistance and obesity. And I know you posed the question to Ben Mickman, what comes first? It's like the chicken or the egg. Ben didn't have an answer, so I'm not going to propose an answer. But there's now just so many mechanisms coming out. These are just things I read this past week, literally papers that came out just this week about, thermic effect of food, brain signaling, about how insulin resistance and obesity are so interlocked. And to look at these mechanisms and think about them in that way, or discussing with you, I know I'm nerding out, but then to compare that to something like eat less, move more, it's just it's shameful at a certain level. That's just, I would consider that, this is a strong statement, but intellectual laziness. Superficially, it makes sense, but you have not delved in to think about what this means metabolically, whatsoever, because it's so much more complicated.
Nick, I've got one question that I want to just ask for one of our members here. They're asking, sure, and maybe you don't have knowledge on this, but they're asking about the PPAR alpha gene mutation that messes with endogenous ketone production. Does that have an effect on dementia? Can you comment on that, or do you have any knowledge about that particular? I know it's not about, there's millions of mutations, so it's hard to say, but
yeah. I don't know off the top of my head if there is any. It would just be association data between PPAR gamma point mutations and Alzheimer's prevalence. You could go to SNPpedia and look it up. I would assume maybe, but it's going to be one of those things that on an individual level is lost in the noise. I do think that though it intersects. No, that's never mind. That's LXR, RXR. I don't have off the top of my head. We can look it up even now, but information on that particular polymorphism and Alzheimer's disease prevalence. PPAR gamma controls a lot of aspects of metabolism and mitochondrial function. So there almost certainly is an intersection. But the degree to which that's influenced by, a ketogenic diet in, say, an ApoE4 state in an elderly individual versus a younger individual, plus peripherally versus centrally, is a really complicated question. And that's one of the trickiest things about neurometabolism, is the rules that apply peripherally don't often apply centrally. So things like, you talk about ApoE, and ApoE is in the periphery, and if you have ApoE4, it preferentially binds VLDL rather than HDL in the periphery, but that doesn't hold true in the central nervous system. There are a lot of things and ratios that are flipped because of this blood-brain barrier. Even things like insulin. We know insulin is in the brain, and there are insulin receptors, and it's very important. We still don't know to what degree insulin's being made in the brain versus being transported into the brain. So brain metabolism in humans gets really, really messy because it's next to impossible to study it in vivo in humans. You have to use mouse models. In terms of models, neurological diseases are probably the hardest to study in rodent models because our brains are just so different. So especially things like autophagy, to do that, people talk about autophagy being activated in the brain 16 hours after a fast, and I kind of laugh because to demonstrate that, you literally have to take humans, fast them for different periods of time, then chop their heads off and stain for LLC2, LC32 or something. It's you can't do those experiments. So a lot of it is extrapolation and speculation. But that's a long political way of dodging your question to say, I actually don't know, but that's a good question. I should look it up.
Yeah, I mean, the point you make at the end, it is very difficult to do definitive studies in humans because you don't get to cut them open at the end. And I mean, not generally, not in the study design anyway. You might have some autopsies you've looked at, but you can't lock everybody in a metabolic ward for 50 years and then cut everybody up at the end. So we find the stuff definitively. Let me unfortunately, I've got to get on a plane here in a few minutes, but I wanted, because this has been fascinating, Nick, and hopefully we'll do it again. But you talked about, everybody has a role, and I'm kind of the instigator, the loudmouth guy that pisses people off, but I think it needs to be done. And you've got, you say you want to approach this from a more academic situation. I appreciate that. I mean, I really do. I think we all need to come together because I think the status quo is not a good place, and I think we have to turn it around. So
I don't want to. I hope I didn't use the term academic. I think it was like all I was trying to say. This was in prelude, just for everybody else. Me and Sean were DMing back and forth beforehand. I was a little bit anxious about getting on MeatRx, being someone who, publicly speaking, even though I've revealed to you already here that I'm more animal based, I have a book coming out next week on Mediterranean keto, and I often hedge, and I'm the kind of person that always plays devil's advocate about whoever, whatever. So if you were going back and forth, Sean, I'd probably play devil's advocate about like plants. And I was talking with a plant person, I'd definitely go wholehearted carnivore. But the point I was just trying to make in defense of myself is this awkward position I find myself in, where I'm early in my career. I think I know a bit, but I definitely don't have the ethos that someone like you has, or the track record. And I'm also in an awkward predicament, being affiliated with pretty conservative institutions and having to manage my message so that it's maximally received and I can have the biggest impact. So, just imagine for a second, Sean, if you were shrunk down literally to my size, I guess, because you're a lot bigger than me. And we're a student entering at Harvard Med, and you were walking around saying the things you say on Twitter there. Like, even if you're spot on, it would just create pushback. Like, in that ecosystem, I will be very unproductive coming forward with that message. Whereas if I hedge a little bit more conservative, or take what I would consider, say, the Trojan horse approach for something like keto, and then combine it with Mediterranean, which is a lot more palatable to the masses, I think that's a lot more tactful given where I am in this larger chess game. So all I was saying is I appreciate everything that everybody does. And we have the bulldogs like Tro and you, and I love it. I get kicks out of watching you guys on Twitter. It's just, I see my role as a little bit different. And sometimes I say things, I hedge a little bit more than my true convictions would reveal, including if you read my stat piece from last week, like I very much intentionally play the role of young person who had a particular experience, is now just questioning things abstractly. I say things like, am I biased because of my experience, or is the standard community biased because they haven't had my experience? Credit actually to that rhetorical posed by Gary Taubes, but I think those kind of questions where I'm being less direct and concrete and say, I'm going to hit you with 30 papers proving my point, is actually where I can loosen things up, then titrate in the message, and then, later down the line, they'd be more open to something like carnivore. I mean, I guess in wrapping up, Sean, I'd ask you, you could presumably do a one-hand push-up, I would guess, but how do you get to doing a one-hand push-up? You don't just go from doing knee push-ups to doing a one-hand push-up. So you have to kind of titrate the message in. And I see myself as kind of higher up in that cascade of titrating it in with something like my cookbook, Mediterranean Keto, which I stand by. I really think it's a good book. But, that opens people up. And then you kind of just, move them along and make them realize that this is a much more complicated and controversial space they've been led to believe by, say, the USDA.
Yeah, I think that there's obviously sorry, my dogs are barking there. There's definitely room for nuance and hedging, and I don't pretend to know everything. I said the only thing I know for sure is I'm wrong about something, what that's going to be. is still to be found out. That's for
Arthur
sure.
Kornberg, right? 57, Nobel laureate, said half of everything we know is wrong. The art of science is figuring out which half, something like that.
Yeah, and then it changes constantly as you discover. There's more and more nuance and more factors that go into that. Well, Nick, this has been wonderful. Thank you very much. Like I said, unfortunately, I have to go get on a plane here in just a few minutes.
Yeah.
So,
no.
Let me just say that, you know, if you want to talk about some other things, we'd love to have you back. I could just from the comments, I could tell everybody really enjoyed this. And so good luck to you at Harvard. You know,
Thank you.
Represent our little low carb community. And I think, you know, we've got a bright future, and I think hopefully we'll continue to, you know, push against this stuff, because what we're doing right now is not working, and we've got to do something different. So,
yeah, I think we can all agree on that. I don't think there's any debate about what we're doing is not working, but thank you so much for having me on. Apologize if I was a little bit, I don't know, overly intense.
You're fine. You're you.
And flexing. I was excited. Yeah. This is new for me. It's been really wild since I only got my PhD back in November, the kind of connections I made and the amazing people I'm meeting like you. So I'm still warming up to this. So, you know, I maybe express some confidence, but every time before I come on these things, especially with people like you, I get a little bit jittery, but it's really exciting to be on. So if you ever want to talk again, we can choose a more focused topic. And I promise not to do, you know, my quantum bounces all around, kind of like I was doing today with Tug and ApoE or whatever, but I really appreciate it. Thank you for having me. I enjoyed this discussion.
Yeah, I mean, yeah, Nick, if you have a focused topic you want to do a little hour-long dissertation on, that'd be awesome.
That'd be fun.
All right, guys, I got to run. We'll see everybody later. You guys take care.
Have a nice flight.